Hello everyone. My name is Sonia Lamba and currently I'm working as an assistant professor in Department of Computer Science. Today's topic of discussion is the properties regarding the relations. So before starting with the topic, we have to understand what is the relation. So a relation is the set of the ordered pairs that satisfies the condition of a relation. So the ordered pairs that does not satisfies the condition of a relation will not belongs to the relation. So relation is nothing but the set of the ordered pairs as per the condition of the relation. We have the different properties that can be defined on the relation. First one is the reflexive property, and a relation is said to be the reflexive relation if a relation is having the reflexive property. So a relation R, which is defined on the set A, is said to be a reflexive relation if and only if for every element A which belongs to the set A comma A ordered pair belongs to the relation R. So we can say that ki for every element of the set A, element must be related to itself, then only the relation is said to be the reflexive relation. We can take an example of this as well. Let's suppose we have the relation R, which is having the ordered pairs 1 comma 1, 2 comma 1, 2 comma 2, 3 comma 2, 2 and 3 comma 3, which is defined on the set A, which is having the three elements 1, 2, 3. Now we have to check that this relation R, which is defined on the set A, is reflexive or not. So here we can see that for every element A which belongs to the set A comma A ordered pair is in the relation, like 1 comma 1 is in the relation, 2 comma 2 is in the relation, and 3 comma 3 ordered pair is also in the relation. That's why this relation is said to be the reflexive relation. Next type of property of relation is irreflexive, and a relation R, which is defined on the set A, is said to be irreflexive if for every element A which belongs to the set A comma A does not belongs to R. If for every element A comma A ordered pair does not belongs to R, then we can say that the relation is irreflexive relation. For example, let's say R be the relation having the two ordered pairs 2 comma 1 and 3 comma 2, which is defined on the set A having the three elements 1, 2, 3. Now we can say that this relation R is irreflexive relation because A comma A type of ordered pair does not belong to the relation R. That's why this relation R is the irreflexive relation. Next category of relation is non-reflexive relation, and a relation R, which is defined on the set A, is said to be non-reflexive if some elements related to itself, but there exists at least one element which is not related to itself. Now, if the relation violates the property of reflexive and irreflexive relation, then we will say that relation is non-reflexive relation. For example, for some elements A comma A ordered pair belongs to R, but for some it does not belongs to R, then in that case relation is said to be non-reflexive relation. Like we can say in this example, relation R is having the three ordered pairs 1 comma 1, 2 comma 1 and 3 comma 2, which is defined on the set A having the three elements 1, 2, 3. For one element 1 comma one ordered pair is in the relation, but for 2 and 3, 2 comma 2 and 3 comma 3 ordered pair is not in the relation. That's why this relation is not reflexive. This relation is not the reflexive, but the relation is said to be non-reflexive because for some elements uh, A comma A ordered pair is in the relation, but for other elements A comma A ordered pair is not in the relation. So this is the third category of the relation. Next we have the symmetric relation. A relation R, which is defined on the set A, is said to be a symmetric relation if whenever A comma B ordered pair is in the relation, then B comma A must belong to the relation. If this property is satisfied, then only we will say that the relation is the symmetric relation. For A comma B ordered pair, B comma A must belong to the relation R. So here we can see in this example, let's say R is the relation having the four ordered pairs 1, comma 1, 1, comma 2, 2, comma 1, and 2, comma 2. Here we can see that whenever is there in the condition, so whenever 1, comma 2 is in the relation, then 2, comma 1 must belong to the relation, then only the relation is said to be the symmetric relation. Or here we can see ki when 1, 2 is there, 2, comma 1 is also there. That's why we can say that this relation is symmetric relation. For the the condition for the symmetric relation is whenever A comma B ordered pair is in the relation, then B comma A must belong to the relation. Now we have the next type of relation or property of relation, which is said to be the asymmetric relation. Now a relation R, which is defined on the set A, is said to be asymmetric relation if whenever A comma B belongs to the relation, then B comma A does not belongs to the relation. So whenever A comma B is in the relation and B comma A is not in the relation, in that case, we will say that the relation is asymmetric relation. So here in this example, we can see that R is the relation which is having the three ordered pairs 1, comma 1, 1, comma 2, and 2, comma 2, which is defined on the set A having the three elements 1, 2, 3. In this relation, we can see that whenever 1, comma 2 is in the relation, so for this 1, comma 2, 2, comma 1 is not in the relation. That's why we are saying here the relation is asymmetric relation. Next type of relation is antisymmetric relation. So let's say R be the relation which is defined on the set A, and this relation R is said to be antisymmetric if and only if A comma B is in the relation and B comma A is also in the relation, then A must be equals to B. So if A comma B and B comma A ordered pair, both the ordered pairs belongs to the relation, in that case A must be equals to B. But if only A comma B is in the relation, then in that case also we can say that relation is antisymmetric. Antisymmetric relation property is whenever A comma B and B comma A is in the relation, then A must be equals to B. So here in this example, we can see R is the relation which is having the four ordered pairs 1, comma 1, 1, comma 2, 2, comma 1, and 2, comma 2, which is defined on the set A having the three elements 1, 2, 3. Now this relation is not antisymmetric because in this relation ordered pair 1, comma 2 is in the relation and ordered pair 2, comma 1 is also in the relation, but 1 is not equals to 2. That's why we are saying relation is not antisymmetric. Next property of relation is transitive. So a relation can also be a transitive relation if and only if whenever A comma B ordered pair is in the relation and B comma C ordered pair is in the relation, then A comma C ordered pair must belong to the relation. Then only we will say that relation is a transitive relation. So here in this example, we can see whenever 1 comma 2 ordered pair is in the relation and 2 comma 3 is in the relation, so for these two pairs 1 comma 3 ordered pair is also in the relation. So here we can check for each and every possibility, and if the transitive property is satisfied, then only we will say that the relation defined on some particular set is a transitive relation. So these are the 7 properties regarding the relation. Now, next we have the type of relation which is said to be the equivalence relation. So, a relation R which is defined on the set S is said to be an equivalence relation if and only if that relation is reflexive, symmetric, and transitive. So, we can say that a relation which satisfies the properties of reflexivity, symmetricity, and transitivity is said to be the equivalence relation. So for reflexivity, we will say that for every element A belongs to the set A comma A ordered pair must belong to the relation. For symmetricity, if A comma B ordered pair is in the relation, so for that ordered pair B comma A ordered pair must also belong to the relation. And transitivity property says if A comma B is in the relation and B comma C is in the relation, then A comma C ordered pair must belong to the relation. So for a relation to be an equivalence relation, these three properties must be satisfied. If one of the property violates, then in that case we will say that relation is not an equivalence relation. Next type of relation is partial order relation. So a relation R which is defined on some set A is called a partial order relation if and only if it satisfies the three properties known as reflexive, antisymmetric, and transitive. So if a relation is reflexive, antisymmetric, and transitive also, then in that case, we will say that relation is a partial order relation. Otherwise, relation is not a partial order relation. Here, important note is कि if a set is there with some partial order relation, then together they are said to be the partially ordered set or O set. Thank you, everyone.